Welcome to my channel. So in this video we'll see the syllabus of scientific computing using a Python and introduction to the Python. About me, a small information is given. Usually we give in our first class. Course learning objectives. It includes the basic numerical algorithms covering interpolation, integration, differentiation, ordinary differential equations and partial differential equation solvers and basic linear algebra. COs are they? Just pause it and go through. CO1, CO2, CO3, CO4, CO5 and map to the different levels of POs and PSOs. It's a content. Unit 1, Unit 2, we have a Unit 3, Unit 4 and the textbook we are going to refer is this particular book, Learning Scientific Programming with Python. How the book looks. So just image is shown to you people. And the prerequisite, no need to know any coding. If you don't know, it's still better. If you know, then okay. It is a added advantage. We'll start first Unit 1. Introduction we'll discuss now. This is called as a Python shell, where you can enter the Python commands. Numbers, variables, comparisons and logic we are going to discuss now. Types of numbers, we have an integer. You have studied in C language in your first year. Floating point numbers and complex numbers. Integers we have such as 1, 8, minus 72 and no limit to their magnitude. Integer arithmetic is exact. Real number examples such as 1.2, minus 0.36. They represent but are stored in binary to a certain precision. It's very important. You have to remember this, which is helpful. Later also remember 4 by 3, 1.3333 will get, but somewhere you have to stop. Python floating point number examples are 2.0, 1.23, e raised to 4. We may use capital or lowercase. In Python, complex numbers denoted by J. Real and imaginary numbers represented as a floating point number. Complex number arithmetic is therefore not exact. Some examples are shown. 2.3 plus 1.2j. We can write like this also. You can represent like this also. Or you can write complex in the bracket 2.3, 1.2. When you type 5, you will get a 5. If I type 5 point something in front of the shell, what I'll get? Prompt you can say, I'll get a 5.0. If I type 0.10, what I'll get? Try to answer, use your brain and see the answer, compare what you wanted to answer. 0.001, if I type, what I'll get? Okay, see the answer. 0.0001 only I'll get. If I type 0.0000, what I'll get? Use your brain, just tell yourself, no need to tell to me, and compare your answer. It is a 9.9 e raised to minus 0.5. Read this. You can pause and read this. Python interpreter display the numbers in a standard way. The internal representation of 0.1 discussed is earlier is rounded to 0.1. Numbers smaller in magnitude than 0.0001 are displayed in scientific notation. That's the reason why you got like this answers. If I type float of 5, I'll get a 5.0. Int of 5.2, what I'll get? Yes, 5. Int of 5.9, correct. 5 I'll get. Complex of 3 point, if I type, I'll get 3 plus 0j. complex 0 point, comma 3 if I type 3.0. Now answer will be 3j I'll get. So read it. You can pause and try to understand. Note the floating point number is rounded down to casting it into the integer. Constructing a complex object from a float generates a complex number with the imaginary part equal to 0. To generate a pure imaginary number, you have to explicitly pass two numbers to complex with the first real part equal to zeros. So far I discussed the types of numbers. Just try to recall. Take a 5 seconds or 10 seconds. Just recall what you have discussed. Integers, floating point numbers, complex numbers we have discussed. You can pause or you can go through the video once again. Let us go to the next. Same a program is written. I used a print statement so that I can see the result on the screen using any online simulator which will display the result on the screen. Float of 5, I told 5.0. The same thing I have typed, program it is, and I am observing the output on this screen. 5.0, 5, whatever we have discussed, the same thing is I got as an output in the computer. You can just pause the video, compare these things and this. Basic Python arithmetic operators. Addition, subtraction, multiplication, all of you will be knowing. Only one extra which you have to remember is floating point division, integer division. Modulus also you will be knowing, exponential also you will be knowing, but these two you have to remember. Floating point division always returns a floating, integer division always rounds down to the result. This is the one point which you have to remember. 2.7 divided by 2 I will get 1.35. Similarly 9 by 2 I will get 4.5. 8 divided by 4. It is not 2, it is a 2.0. And this can perform an integer arithmetic. And say 8 divided by 4 only I am doing it because it is integer, I will get 2. Similarly 9 divided by 2 I am doing integer division. What I will get? 4. Similarly 2.7 divided by 2 integer division. I will get a 1.0. Pause the video and try to understand. Take a 3 seconds. The same program is typed and executed, and whatever we have discussed so far, the same results we got. You can pause the video or you can just go through. You have another 6 seconds. Let us go to the next. Modulus operator. So 9 modulus 2. I got 1. 4.5 modulus 3. 1.5. The same thing I executed. You can observe the output also. Again, the number returned is an int only if both of the operands are int. You can pause the video. Try to tell the answer. Is it a 14 or 18? So I'll show you the result. Two plus 4 into 3 will lead to 14 as 2 plus 12 or 8 as 6 into 3. See, the answer is 14 because multiplication has a higher precedence than addition. So please read this sentence twice. And Python arithmetic operator precedence are given here. Highest is the exponential. Then lowest is a plus minus. And if I use a parenthesis, then it will be 18. Let us go to the next. The same program I executed and I got the result. Observe it. You have 5 seconds. Let us go to the next. Operator precedence. 6 divided by 2 divided by 4. If I do, answer will be 0.75. It is same as 3 by 4. Similarly, read the remaining. 6 divided by 2 divided by 4. Now I use a parenthesis. It is same as 6 divided by 0.5. This also try to understand. It is nothing but a 2 exponential 8. If I use a parenthesis, it will become 4 exponential 3. You have another 6 seconds. Pause if you want. Otherwise, let us go to the next. And this we are using for a comment. The same program I have typed and I have executed, and the results are same what we have discussed just now. So far I have discussed all these things. Pause the video for go through. I'll wait for another 6 seconds. Let us go to the next. Methods and attributes of numbers. Python numbers are objects. In fact, everything in Python is object. Has certain attributes accessing using a dot notation. 4 plus 5j dot real means I'll get a 4.0. 4 plus 5j dot imaginary I'll get a 5.0. Callable functions 4 plus 5j dot conjugate I'll get a 4 minus 5j. And if I say 38 some number I have typed dot bit length I'll get a 52. The empty parenthesis indicates that the method is to be called. I'm using here bit length conjugate. Python allocates as much memory as is necessary to exactly represent the number. Try to understand why it is 52. I'll wait for 5 seconds. Let us go to the next slide. This is a program I have executed, the same results I got. Observe the program and see the bit length. What I told one line, you will understand by observing this. Why it is 52, why it is 3. Use your common sense and try to understand. Mathematical functions are there. You can use a like this, absolute minus 5.2 you will get a 5.2, absolute minus 2 you will get a 2, absolute 3 plus 4j you will get a 5.0. It's very important, one word you have to understand. This is an example of polymorphism. Is one word is given to this. What is this, sir? The same function ABS, absolute, does different things to different objects. If passed a real number x, it returns a x absolute. The non-negative magnitude of the number without regard to sign it will return in second case. Third, you will get a, if a z equal to x plus y, iy if you give, you will get z equal to x square plus y square. So this is a one word which you have to remember and you have to understand. Mathematical function, a program is executed. Try to understand. Whatever we have discussed, the same results we got after execution. You can execute in any online simulator. Try to understand these. You can pause the video. I'll wait for another 4 seconds. From this, try to conclude something. Observe carefully here. When I wrote around 7.499999 and 7.5 I wrote, 7.49 I got round, but answers are not same. Why so? Use your brain. Think. Give work to your brain. Pause here. Simulate like this many times and try to understand why. And answer is already told in this particular video. Let us go to the next. So far we have discussed these things. Just take a 10 seconds to revise whatever you have discussed so far. Let us go to the next. Some functions provided by the math module. Math square root of x, exponential of x, log of x. You can write sine of x, cos of x. Like this you can use. You can write an instruction and simulate. And one point you have to remember, angular arguments are assumed to be in radians. So you can use these functions and write a small program or a set of instructions and execute and try to understand. Similarly, few more are listed. You can execute these things. A degree of x converts x from radian to degree. Like this, many functions are available. Simply use this and try to understand. Some functions provided by the math module, import math you have to write. This is one important point. Math dot exponential minus 1.5, what I will get? Math cos of 0, I will get 1.0. Math square root of 16, I will get a 4.0. The math model also provides a two very useful non-function attributes, math.py and another is a math.e. So these two will get. One important point which you have to remember. And sample I executed, import math I have written, then print math.exponential minus 1.5. The answers I got the same whatever I have discussed so far. Observe it, you have another 5 seconds. Function concatenation is possible. I used here math.sin math.pi divided by 2. So concatenation is possible. And I got an answer. Whatever 1.0 I can observe in the result. Here I got math.degree.math.a cos of math.square root. Like this I have concatenated, I got an answer. Let us go to the next. For more information, you can visit my blog. You can visit my YouTube channel. And thanks for watching this video. Share this video if you like. Subscribe my channel. Thank you.